Right, okay. Today I am going to discuss about the test method of the estimation of hemoglobin. There are different methods to detect the hemoglobin level of a patient. Some are visual methods, some are the photometric methods. Visual methods are very simple but not accurate, and the accurate methods are photometric methods. Out of those, there are two types of photometric methods available. One is oxyhemoglobin method and the other one is cyan-meth hemoglobin method. Out of these two, the cyan-meth hemoglobin method is the best one. Why? With that method, all the hemoglobin present in the human body is detected except salt hemoglobin, SH. And also the standard using this one, or the cyan-meth hemoglobin standard, is very reliable as well as it is a stable standard. We can keep this standard up to 1 year or more than 1 year if we keep it in a closed container in a refrigerator or dark place. Right, okay. For the estimation of hemoglobin with cyan-meth hemoglobin method, we want Drebkin reagent where the pH is going to be 7 to 7.4 and a standard HiCN standard blood sample, EDTA, capillary blood we can take, and test tube, cotton wool, 5 ml pipette and a 20 microliter pipette. Other than that, we want a colorimeter or spectrophotometer with a cuvette in that one to measure the absorbance of the solution. So what we are going to do first we take 3 test tubes and label them as test T, test, standard S, standard, and blank, B, blank. Then take the Drebkin reagent, and measure 4 ml of Drebkin reagent, or put 4 ml of Drebkin reagent to the tube labeled as test and blank. 4 ml of Drebkin reagent to the tube labeled as test and blank. So we can put directly the standard to the tube labeled as standard. We put directly the available reference standard to the tube which has been labeled as standard. Then when we are using the blood sample, we have to wear gloves. Because of that, I wear gloves, pair of gloves. Always we consider the blood sample and the sample as the pathogenic sample or infect risk samples or the risk material. So because of that, we wear a pair of gloves and make the EDTA blood sample homogeneous by inverting it 8 times. Mix well by inverting it in 8 times. And they take the 20 microliter pipettes, 20 microliter micropipette. You can use automatic micropipette or glass pipette. Remove the tube cap and then take blood just above the mark of the 20 microliter, just above the mark of the 20 microliter. Then adjust the meniscus, up to 20 microliter mass and wipe off the surrounding one. You have to adjust it up to 20 microliter mark and wipe off the surround and rinse the 20 microliter in Drapkin reagent present in the tube labeled as T. Rinse it in the Drapkin reagent present in the tube labeled as T. Mix it well. Mix it well. Now what is going on that one? Then we allow to stand it about 5 minutes for the conversion of hemoglobin into cyan methemoglobin. In the Drapkin reagent, it has potassium cyanide and potassium percyanide. With the help of potassium percyanide, the hemoglobin present in the blood sample converted into methemoglobin, and then methemoglobin is going to be converted to cyan methemoglobin with the potassium cyanide present in this Drapkin reagent. This Drapkin reagent is very important. Why? The color of this is going to be somewhat pale yellow in color, somewhat greenish yellow in color actually. The pH is going to be around 7.2, 7 to 7.4 is ideal, and it has not to be, the solution must be clear, no turbid should be there. And also if we take the absorbance of this one at 540 nanometer, it has to be 0. Against the distilled water, the absorbance of the Drapkin solution must be 0. If it is indicate some amount of absorbance, we have to discard this solution, prepare fresh solution, and we can use the fresh solution if it is also not having the absorbance against distilled water. And the conversion time of the hemoglobin into cyan methemoglobin with this solution is 3 to 5 minutes. Within 5 minutes, almost all the hemoglobin is going to be converted into cyan methemoglobin, and the produced cyan methemoglobin, this is my test, this is my standard. The produced cyan methemoglobin is going to be stable for an hour, but in the other method, oxyhemoglobin method, the produced hemoglobin is not much stable as this. Okay, now it has been gone 5 minutes. Now I have been test standard and the blank. Then I switch on the colorimeter or spectrophotometer, and then I select 540 nanometer, 540 nanometer. Filter. Then this is my cuvette. This is the cuvette, and I put distilled water into the cuvette and wipe off the optical pathways of the cuvette and put it there, and zero the instrument. The absorbance of the instrument has to be 0. Now it is minus 15. I have to make the absorbance 0. Absorbance 0. Then I can discard it. Then I have to measure the blank absorbance. This is my blank. Put the blank Drapkin and measure the absorbance. What is the absorbance? It has to be 0. My Drapkin is good. It means the no absorbance there. It is 0. Then we are going to be take the absorbance. I can see the color of this. The test color is somewhat low and the standard color is high. Because of that, I take the absorbance of the test first. The low one or the less color one has to be taken first. The absorbance of the test, it is going to be 0.033. I am going to be write it here. Absorbance of the test 0.033. Then I can take the absorbance of the standard. The absorbance of the standard is 0.38. And also I know the 0.38 is the standard absorbance, and also then wash off your aqueous. Wash off your aqueous and put it there. Switch off your instrument. Now I have the absorbance of the test. It is 0.033, and also the absorbance of the standard, it is 0.38. I know the exact value of the standard. It is 13.5 gram per deciliter. 13.5 gram per deciliter. That's why we say it is a standard. We know the concentration of the standard. What I have to do now, I have to find out the value or the actual value of the patient or the concern hemoglobin of the test. How I am going to do? I divide absorbance of the test by the absorbance of the standard and multiply by the concentration of the standard. You know the absorbance of the test 0.33, and the absorbance of the standard 0.38. The concentration of the standard is 13.5 gram per deciliter. You can take the you can take the concentration of the test by solving this equation. 0.33 is divided by 0.38 and multiply by 13.5 gram per deciliter. Finally you will get the results of the patient hemoglobin level. Right, this is the procedure of the cyan-meth hemoglobin technique. Instead of the cyan-meth hemoglobin or the Drapkin reagent, in the oxyhemoglobin method we use ammonium hydroxide, which convert hemoglobin into the oxyhemoglobin. The problem is those produced oxyhemoglobin is not going to be stable as the cyan-meth hemoglobin, and also the produced all the hemoglobins are not going to be converted into oxyhemoglobin, but in cyan-meth hemoglobin almost all the hemoglobin except sulfhemoglobin, which is very minute amount, going to be present in the patient body, as well as some people are not going to be have sulfhemoglobin, which is a combination of sulfonamides and hemoglobin, right? So because of that we take, this is the very accurate method of the measurement of hemoglobin, and also the principle behind this is, I told that the conversion of hemoglobin into the cyan-meth hemoglobin with the help of potassium pericyanide and potassium cyanide, and the principle behind the colorimeter or the spectrophotometer is Beer-Lambert law. You will be learn about that under chemical pathology. Thank you very much.